Let me continue with that deep learning. One advantage of deep learning is that having more layers allows for richer intermediate processing and representation of the data. So in that way, each layer the data is going to be formatted and to be better utilized by the next layer. So this process increases the efficiency of the overall result. Now you can see that here in the previous slide. There are 3 filtering layers are there. First layer, second layer, third layer, to represent whether it is a dog or wolf. So the training set is going to be there first, the input is going to be given, unnamed input it is going to be, and you should identify that whether it is a wolf or dog. So first layer filters something, second layer again it is getting filtered, then third layer the complexity of that is going to be checked properly, and all the animals are going to be layer by layer that it is getting filtered, and finally the 90% of the symptoms whatever that it is going to be there, the vision is going to be there, the picture is going to be there, that is going to be represents a dog, not an wolf. Okay, so deep learning focuses on these things. How many number of layers that we will be going to have, that much better quality of the output that we will be going to get. Machine learning and getting the intelligence from the big data. So now machine learning is one of the concept of this big data. It is going to be where data is going to be there, and you should understand how that is going to be analyzed. So when these principles are going to be the machine learning principles are very clear, and applications to the IOT obviously. Okay. So ML, that is machine learning operations, are categorized into 2 broad subgroups. One is local learning and another is remote learning. So local learning is nothing but where data is collected and processed locally, either in the sensor itself, is nothing but an edge node, or in the gateway, that is a fog node it is. Here we can say that a simple way that a vehicle is going to be moving, then sensor senses some of the humps over there. Now whether the sensor is going to take its own decision or the fog should be forwarded to the fog. So now here it is a learning concept is going to take place. So already if the threshold levels, if it is going to be there, then a sensor itself can be taken care. Otherwise that should be given to the upper layer, that is a fog node. Then another concept, another learning is remote learning is there. So here the data is collected and sent to the central processing unit, or we can say central computing unit. The data is where it is, that will be stored in the cloud, where it is, that is going to be get processed. So example for this is data, there is vehicle tracking is one of the example that we can say. So number of vehicles are going to be there, and all these things, if it is a GPS enabled and it is getting stored, all the data are going to be stored over there. If any vehicles are going to be moving, that it can get tracked through remote location. Common applications of machine learning for an IoT is a major domains are there: monitoring, behavioral control, operations optimization, and self-healing and self-optimizing. Now monitoring, where this IoT device comes in the picture. So if as we have already taken the example for that, in a vehicle thermometer is going to be kept, and it is temperature is getting recorded. So it is monitoring status will be there in this monitoring. So it is already thresholds are going to be fixed, and if it is going to be going up and down, okay, If it is down, there is no problem. But in case of there also the threshold is going to be minimum and maximum thresholds are going to be kept. So based on that, the monitoring is going to be done, and the actions are going to be taken locally. That it should be taken. For example, a pressure gauge is going to be there. With that pressure gauge, the threshold is going to be some number is going to be present. So if it is going to cross that threshold level, then there is a danger. So immediately the it should be opened. That is action is going to be taken on that. Okay. So by monitoring that is possible. Then there is a behavioral control. Again, changing the data, changes in the data. For example, here, behavioral control. A car is moving with the speed of around 60 kilometers, and suddenly there is within a few meters, you are finding that there is a animal is passing. So behavioral change, you are seeing that, and immediately that animal's behavior that you'll be going to see, and immediately that you'll be going to take the action on it. So you'll be going to apply the brake. So based on that behavioral controls, that it is very, very important thing, and you should be always be cautious. And even some sensors that will sense that these things, information, and given to the fog, and action is going to be taken with the fog. Next set is domains are operations optimizations. A number of here it comes with the concept of companies where the data is going to be, the operations are going to be maintained automatically. So when you are maintaining automatically, sometimes the optimization of that also it is requires. So reason is for that is when input is going to be more, you are feeding, output is less. It means to say that the input data, whatever that you are passing, the output is not coming at the same time, faster. Products are not coming out with the same format. So what happens? The input is getting stored over there. Sometimes what happens? Input is fast, input is slow, output is going to be fast. So at that time what happens? Again there is a storage that you have to keep it. Okay. So basically you have to maintain the balance in this. Operations are going to be optimized. You have to see the requirements, based on that the actions are going to be taken. Self-healing and self-optimization. This all comes under the same categories of operation optimizations. Let us see the big data analytics tools and technologies, how that is going to perform. This big data analytics can consist of many different software pieces that together collect, store, manipulate, analyze. These are the four important tasks. Together they will collect, store, manipulate, and analyze all the different data types. So which helps to better understand the landscape by defining what big data is and what it is not. So we have to differentiate between this what is big data and what is not a big data. So to identify this, there are 3 B's are there to identify whether it is big data or not. Let us see what are these 3 B's. 3 B's are velocity